All right, enlargement. An enlargement is a transformation in which the object is expanded or reduced onto the image from a fixed point called the center of enlargement. All right, here, what I'm going to do is I'm going to, um, first of all, an enlargement needs at least two components. You need to know the center of enlargement and you need to know the scale factor. What I'm going to do first is I'm going to enlarge triangle ABC, or I'm going to enlarge um, triangle ABC by a scale factor of 2, and the center of enlargement is the origin. All right, so the scale factor is 2, and the center of enlargement is the origin. Here's how we're going to do that. First of all, we're going to note the distance from, let's say, the object to B. Sorry, from the center of enlargement to B. From the center of enlargement to B, I'd have to go 2 units to the right and 2 up. So 2 units right, 2 up. That's from the center to B. All right. Now, to get to the image B prime, I'm going to double that distance. The reason I'm going to double that distance, it's good because the scale factor is 2. So I have to go 2 right, 2 up. So I'm going to go 4 right, 1, 2, 3, 4 right, 1, 2, 3, 4 up. That brings me to the new position of B. This is B prime. All right, um, so in a sense, the distance from the center to the image is k times the distance from the center to the object. From the center to the object is 2 right, 2 up. To get to the image B prime, because the scale factor is 2, I must double that distance to 4 right, 4 up. From the center to C, it's 4 right, 2 up, 4 right, 2 up. To get to the image C prime, I must double that distance. So it's going to be 8 right, 4 up. 1, 2, 3, 4, 5, 6, 7, 8. 8 right, 4 up. 1, 2, 3, 4. This would be the new position of C. This is C prime. From the center to A, it's 2 right and 1, 2, 3, 4, 5, 6 up. 2 right, 6 up. Now, because the scale factor is 2, I must double that distance. So it's 4 right, 1, 2, 3, 4, and 12 up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That will give me the new position of A. This would be A prime. So now all that remains is for me to connect the points. So you'd use a ruler to connect the points. So ABC is the object, and A prime, B prime, C prime is the image, and K, the scale factor, is equal to 2. All right, next I'm going to draw A double prime, B double prime, C double prime. So this one now is going to be an enlargement, center, origin, and scale factor a half. So from the center to B, it's 2 right, 2 up. If I half, that is going to be 1 right, 1 up. This would be the new position of B. This would be B double prime. From the center to C, it's 4 right, 2 up. Half that, 2 right, 1 up. This is the new position of C. This is C double prime. From the center to A, it's 2 right, 6 up. You're going to half that because the scale factor is a half. It's going to be right, 1 right, 3 up. 1, 2, 3. This would be the new position of A. This would be A double prime. Use your ruler and connect the points. All right. Now, the final enlargement I'm going to do is an enlargement scale factor -1 and send to the origin. All right. Now, when the scale factor is negative, you're going to go in the other direction. Now, because the scale factor is 1, the distance from the center, the distance, I'm going to go into the opposite direction from the center of enlargement to get to the image. So for example, from the center to B, it's 2 right, 2 up. The opposite direction would be 2 left, 2 down. This would be the new position of B. This would be B triple prime. From the center to C, it's 4 right, 2 up. So it's going to be 4 left, 1, 2, 3, 4, 2 down. That would bring me here. And this would be C triple prime. Last but not least, from the center to A, it's 2 right, 6 up. Because the scale factor is -1, the distance is going to be the same, but it's going to be in the opposite direction. 2 left, 6 down. 1, 2, 3, 4, 5, 6. The new position of A, this will be A triple prime. All right. So here with this image, K is equal to a half. And here with this image, K is equal to 1. All right, so some points to note. When K was more than 1, the image got larger. When K was less than 1, the image got smaller. When K is equal to 1, the object and image are the same size. All right, next I'm going to connect all the C's, draw a line, a straight line through all the C's. That's C, C prime, C double prime. All right, I'm going to see what happens. So I line up all the C's and I draw a line. And what I observed is that if I drew a straight line through corresponding points on the object and on the image, it passes through the center of enlargement. If I drew a straight line through corresponding points on the object and image, it will pass through the center of enlargement. Let us see if the same thing happens when I connect all the B's. All right, when I drew a straight line through all the B's, it passes through, that straight line passes through the center of enlargement. And I'm going to assume that if I connect all the A's, the same thing would happen. All right. So a straight line connecting corresponding points on the object and image must pass through the center of enlargement. When K was positive, the object and the image are on the same side of the center of enlargement. When K was negative, the object and image are on opposite sides of the center of enlargement. All right. So let's go down and list some features of an enlargement. Feature number 1, the scale factor K is equal to the length of one side on the image over the length of corresponding side on the object. In other words, I could say that K would be equal to, let's say, A prime B prime, which is the length of one side on the image over, let us say, AB, which is the length of the corresponding side on the object. And if I have one fraction is equal to one fraction, I can cross multiply. So I could say, therefore, A prime B prime is equal to K multiplied by AB. So in other words, the length of one side of the image on the image is equal to K multiplied by the length of the corresponding side on the object. So the length of the sides of the image are K times the length of the sides of the object. K is equal to the length of one side on the image divided by the length of the corresponding side of the object. All right. All right. So this is just a sort of replica of what we just did. Um, so here the only difference is that we use K being positive a half, not negative a half. But the principle essentially is the same. You can notice that C prime, C double prime, and C triple prime, they're on a straight line that passes through the origin. The same about the B's and the same about the A's. So a line connecting corresponding points on the object and the image must pass through the center of enlargement. Some other features, the distance from the center of enlargement to the image is equal to K times the distance from the center of enlargement to the object. All right, this is a principle that we actually use to obtain the images. That whatever is the distance from the object to the image, we multiply that distance by K to get the distance from the center to the image. So again, whatever is the distance from the center to the object to get to the image, we multiply that distance by K. So in other words, the distance from the center to the image is equal to K multiplied by the distance from the center to the object. When K was positive, the object and the image are on the opposites, are on the same side of the center of enlargement. When K is negative, the object and image are on opposite sides of the center of enlargement. When K was greater than 1, the image is larger than the object. When K is less than 1, the image is smaller than the object. When K is equal to 1, the image and object are the same size. Here we're learning that K squared is equal to the area of the image divided by the area of the object. In other words, the area of the image is equal to K squared multiplied by the area of the object. So those are all features of an enlargement. All right, here's some other stuff. We need to know how to locate the center of enlargement. And I would start off by saying to you that the line connecting corresponding points on the object and on the image is a straight line that passes through the center of enlargement. All right, so a straight line connecting corresponding points on the object and the image, as we have seen before, must pass through the center of enlargement. So the straight line that connected that connected C prime, C double prime, and C triple prime, that straight line must pass through the center of enlargement. So we can use that principle to locate the center of enlargement. How do we do that? First, we have to draw at least two straight lines through two different pairs of corresponding vertices on the object and the image. The center of enlargement is the point of intersection of these two lines. All right, in the next example, we'll get to see this in action. All right, in this example, it says the diagram on the answer sheet shows triangle LMN and its image under an enlargement L prime, triangle L prime, M prime, N prime. State the coordinates of L, L prime, M prime, and N prime. So I guess we can start. From this, we can see clearly L prime is 4, 9. M prime is 2, 5, and N prime is 8, 5, 8, 5. So it's the first thing we're asked to do. This would be I. Next, we're asked to find the center of enlargement, and already discussed this earlier. That if we draw a straight, if we use a straight line to connect, um, if we use a straight line to connect n and n prime, that straight line must pass through the center of enlargement. It is also true that if we use a straight line to connect m and m prime, that straight line must pass through the center of enlargement. And the center of enlargement is therefore where these two lines intersect. So this point here would be my center of enlargement. So we're asked to what? Find C, the center of enlargement. So C, the center of enlargement, is the point C, the center of enlargement, is the point 0, 1. All right. So 0, 1 is the center of enlargement. The third thing we're asked to do is what is the scale factor of enlargement? Earlier, we told you that the scale factor K is equal to length of side on image divided by length of corresponding side on object. In other words, I could say that K would be equal to M prime N prime over M N. From here, we can see that M prime N prime is 1, 2, 3, 4, 5, 6 units. So this is 6. And Mn is 1, 2, 3 units divided by 3. So the scale factor K is equal to 2. Let's correct that. It's actually equal to minus 2. And it's equal to negative 2 because the object and image are on opposite sides of the center of enlargement. Four, we're asked if the area of the object, triangle LMN is 3 square units. All right, that's actually with 3 square units, not 3 square. Use a calculation method to determine the area of the image. So first of all, this shouldn't be a 3 square, it actually should be 3 square units. Use a calculation method to determine the area of the image. L prime, M prime, N prime. All right, this is what we said earlier. So this is IV. We said that K square is equal to the area of image divided by the area of object. So k, which is minus 2, so it's minus 2 square, which must comes out positive, is equal to the area of the image, which is triangle L prime, M prime, N prime, divided by the area of the object, which is triangle LMN, which is 3. So I can say, therefore, 4 over 1 is equal to area of triangle L prime, M prime, N prime over the area of triangle LMN, which is 3. If I have one fraction is equal to one fraction, I would cross multiply. So I have the area of triangle L prime, M prime, N prime is equal to 3 times 4. And that is equal to 12 square units. All right, it's equal to 12 square units. And that should be the end of enlargement.